Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of differentiation, and in today's video we are going to find how to prove the derivatives of basic important functions like log x derivative is 1 by x, a power x derivative is a power x into log a base e power x derivative is e power x. All these things you actually by heart to solve the upcoming problems, right? And in today's video, first we will give you the derivations, how to actually prove that e power x derivative is e power x, cos x derivative is minus sin x, etc. First we will prove how to find the derivatives of these functions, and later in the upcoming videos we'll be using it. Okay, all these proofs will be done using fundamental principle of derivatives. So do watch the video till the end to get exact clarity about how these things are proved. Okay, let us start with log x derivative. And remember this, in our previous video we have already proved that x power n derivative is n into x power n minus 1. We have already proved this in our previous video, so keep this in mind. You can check the previous video if you want more clarity about it. We'll start with log x derivative. Let us first prove that derivative of log mod x is equal to 1 by x. See, instead of writing d by dx of log mod x, we can also write it as log mod x derivative. Okay, now so keep this in mind. I'll be using this notation to write derivatives. Okay, we are going to prove that log mod x is equal to 1 by x. For this, first what I'm going to do is I'll divide it into two cases. In case 1, I'll say that I'll say that x is positive. In case 1, I'll say that x is positive, so which means mod x will be equal to plus x, right? So then f of x, I'll call this function whose derivative you are finding as f of x. Let f of x is equal to log, instead of mod x I'm writing x. So if f of x is log mod x, you are going to find what? F dash of x. So we already know the formula to find f dash of x from the first principle of derivative. What is it, dear students? Limit h approaches 0, f of x plus h minus f of x whole divided by h. So this is the first principle of derivatives. Using this, we are going to prove that log mod x derivative is 1 by x. We are in case 1 where x is positive, so mod x is equal to x. So let me substitute that. Limit h approaches 0, f of x plus h. F of x plus h means log of x plus h. Log of x plus h minus f of x is log x whole divided by x. Now let me use log m minus log n formula. Do you remember from logarithms? Log m minus log n is equal to log of m by n. So I'm going to use that particular formula here. Limit h approaches 0, log of m minus log of n is log of m divided by n whole divided by h as it is. So in our next step, let me separate the common denominator. Limit h approaches 0, log of x by x is 1 plus h by x whole divided by h. See, dear students, in limits chapter we have already learned that if f of x, if some variable approaches 0, I'll write the formula, it's better. Limit for example x approaches a, if g of x approaches 0, then log of 1 plus g of x whole divided by g of x is taking the value 1. When x is approaching a number a, if g of x approaches 0, then log of 1 plus g of x whole divided by g of x is 1. See, observe one thing. Who is that g of x here? When h approaches 0, h by x also approaches 0. Correct or not? So h by x also approaches 0. So limit g of x approaches 0, log of 1 plus g of x divided by should be g of x. In divided by also we need g of x. So here h by x means here also I would like to have h by x. So I divided with x, so I'll also multiply with x. And this is obviously in this form. Correct or not? Its value is 1. And what is remaining? I'm sorry, we should also include this. This is in this form, its value is 1 divided by x is there. So dear students, we have proved that In case 1, log x derivative is 1 by x. Similarly, you can try case 2. What is case 2? In case 1, x is positive. In case 2, x will be negative. Will you try this proof? Try this and let me know whether you got the answer in comment section or not. You just pause the video and try it. Okay, anyhow, I'm explaining it here. So if you have done it, you can check the proof here. So when x is negative, mod x is minus x, right? Then f of x becomes what? F of x is log mod x, right? So instead of log mod x, what I'm writing? Log of minus x, because mod x is minus x. So if f of x is log of minus x, here is the proof of it using first principle of derivative. You can easily understand this. Here we have to be careful, particularly in this step we have to be careful. Okay now, so while writing f of x plus h, so instead of x, I'm writing x plus h, correct or not? So that means what? Log of minus of, instead of x, if you write x plus h, minus is for both terms. So that is where children generally do mistakes. Okay now, so you can go through the proof here, you can easily understand this. Okay, so in case 2 also we'll get the derivative of log x as 1 by x itself. So dear students, so in case 1, the derivative of log mod x is 1 by x. In case 2 also, the derivative of log mod x is 1 by x itself. Therefore, the derivative of log mod x is always 1 by x. Whether x is positive or negative, it does not matter. The derivative of log mod x is always 1 by x. We'll go with next video. Next question. See, after logarithmic function, here we are finding the derivative of exponential function. A power x derivative is a power x into log a base c. Let us prove it again using fundamental principle of derivative. See, let f of x is equal to a power x. Now we are supposed to find f dash of x, the derivative of this. So f dash of x formula using first principle of derivative. Limit h approaches 0. Limit h approaches 0. F of x plus h minus f of x divided by h. Limit h approaches 0. F of x plus h. F of x plus h is a power x plus h, right? Minus f of x is a power x whole divided by h. Next, what am I going to do, dear students? A power m plus n formula. So a power x plus h is a power x into a power h, correct? Minus a power x whole divided by h. And we can take a power x common in these two terms. And we can take it common. You can take a power x out of the limit, because a power x is independent of h. We can take it out of the limit. So a power x into limit h approaches 0. We are left out with a power h minus 1 divided by h. And already in limits chapter we learned this particular limit value. This is log a base e. Therefore, dear students, over the derivative is what? It is equal to log a power x into log a base e. So therefore, a power x derivative is equal to a power x into log a base e. So using this, you can find what is e power x derivative. Can you pause the video and just substitute a value as e here and find what is the derivative of e power x? Yes. So anyhow, I'm explaining it. Then what is e power x derivative? E power x derivative according to this formula is e power x into log e base e. Instead of a, we have taken e. So log e base e value is going to be 1 from logarithm properties. The answer is what? E power x derivative is also e power x. So this is one particular function where its derivative is itself. E power x derivative is e power x itself. Okay. So after this, so we have found logarithmic derivatives. We have found derivative of logarithmic function and derivative of exponential function. Now let us see derivative of trigonometric functions, sin x, cos x, tan x and their reciprocals. Okay, first let us see how to prove the derivative of cos x. So we are doing the derivative of trigonometric functions, in which first we have chosen cos x. Cos x derivative is minus sin x. If I am explaining the derivative of cos x, you must be doing the derivative of sin x. First let me complete this. After that you can see whether you got the derivative of sin x or not. Okay. So as usual, let f of x is equal to cos x, and f dash of x using first principle of derivative is this. Then limit h approaches 0. F of x plus h. F of x plus h is what? Cos of x plus h minus cos x. F of x is cos x whole divided by h. After this, you should remember cos c minus cos d formula from transformations chapter in trigonometry. What is cos c minus cos d? I hope you remember it. It is minus 2 sine c plus d by 2. That means c is x plus h plus d is x divided by 2. c plus d by 2 into sine c minus d by 2. c minus d by 2. So this is c and this is d. Okay, now minus 2 sine c plus d by 2 into sine c minus d by 2. Remember this. We have used cos c minus cos d formula. Whole divided by, let us not forget, h. Next, dear students, we are almost close to our answer. Limit h approaches 0. Minus 2 into sine of x plus x is 2x plus h by 2 into sine of, please observe here, plus x and minus x cancels, so we will get h by 2. Since it is sine of h by 2, I want h by 2 in the denominator. So let me divide h with 2 and then also multiply with 2. The denominator is divided with 2 and also multiplied with 2. So dear students, we know the value of this already. So what is it? Here 2 and 2 will get cancelled obviously. And then in this particular function we can substitute h value as 0. So what do we get? Minus sine of, when h is 0 we get 2x by 2 which is x into, and when h is approaching 0, sine h by 2 divided by h by 2. Sine of h by 2 divided by h by 2. Its value is 1. We learned this already in limits chapter. Sine h by 2 divided by h by 2 will be 1 when h is approaching 0. So therefore, dear students, we proved that cos x derivative is minus sin x. Therefore, cos x derivative is minus sin x. Can you immediately start finding sin x derivative and let me know what is the answer in comment sections? Pause the video and you can try this sin x derivative. And obviously, you will get the answer as what? Cos x plus cos x. Remember, sin x derivative is plus cos x. Cos x derivative is minus sin x. Keep this in mind. So sin x derivative is cos x and cos x derivative is minus sin x. So next, let me prove the derivative of cot x. I am finding the derivative of cot x as minus cosec square x. I am giving you the proof of this. You can try tan x derivative and you can let me know what is the answer. And let us come back to this cot x derivative. So as usual, let f of x is equal to cot x and f dash of x using first principle of derivative is limit h approaches 0, f of x plus h minus f of x whole divided by h. So limit h approaches 0. F of x plus h is what? F of x plus h is cot of x plus h. So cot of x plus h minus f of x is cot x whole divided by h. Don't think about cot c minus cot d formula. We do not have it. So what shall we do? So let me write cot x plus h as cos by sin. That means what? Cos of x plus h by sin of x plus h minus again cot x as cos x by sin x whole divided by h. And let me take common denominator in the numerator. So what do we get? Limit h approaches 0, sin x into cos of x plus h, sin x into cos of x plus h minus cos x into sin of x plus h whole divided by this into this. What is it? Sin of x plus h into sin x, and already in denominator we also have h. Okay, now next let me use sin a cos b minus cos a sin b formula in the numerator. So limit h approaches 0, sin a cos b minus cos a sin b is sin of a minus b. So a is x minus of b is x plus h whole divided by sin of x plus h into sin x into h. Observe one thing here. Limit h approaches 0, plus x and minus x will get cancelled. We have minus h. And we know that sin of minus h is minus sin h divided by, let me write h. In the remaining two terms, in place of h we can substitute 0. What do we get? Sin x into sin x. We will get sin square x in the denominator. And dear students, limit h approaches 0, sin h by h is 1 with minus sign. In denominator we have sin square x, and this is equal to minus 1 by sin square x is cosecant square x. So therefore, dear students, we have proved that cot x derivative is equal to what? Minus cosecant square x. Now can you prove that tan x derivative is secant square x? Can you do it? Same process itself. Tan x derivative is secant square x. You can do it. Okay. After this, let me explain the derivative of cosecant x. No, let me explain the derivative of secant x. You try cosecant x. So we are going to prove that secant x derivative is secant x into tan x, and I have taken f of x as secant x and f dash of x formula using first principle of derivative. So it is limit h approaches 0, f of x plus h. F of x plus h is secant of x plus h minus f of x is secant x whole divided by h. So in the next step, let me write secant of x plus h as 1 by cos of x plus h minus secant x as 1 by cos x whole divided by h. And dear students, let us take common denominator in the numerator. So cos x into 1 zar is cos x minus cos of x plus h into 1 zar is cos of x plus h whole divided by this into this. Cos of x plus h into cos x, and of course h also will come here, right? Now let me apply cos c minus cos d once again. Already we have used cos c minus cos d. So let us once again use cos c minus cos d. So limit h approaches 0. Cos c minus cos d is minus 2 sin c plus d by 2. That means x plus h by 2. C plus d by 2 into sin c minus d by 2. That means what? X minus of x plus h whole divided by 2. And in denominator we already have cos of x plus h into cos x into h. Next, already we have done this model in proving cos x derivative. So what happens? Limit h approaches 0 minus 2 into, here if you substitute h as 0, x plus x is 2x, 2x by 2 is x, so we get sin of x. I have taken h as 0, okay na? And there plus x and minus x gets cancelled, we get sin of minus h by 2, and minus will come outside, so into minus sin h by 2 whole divided by, in denominator we can substitute h as 0, no problem. If we substitute h as 0, I'll get cos x into cos x, which is cos square x into h. See dear students, minus into minus will become plus, and at the same time what I am doing is sin h by 2 is there, here also I want h by 2, so I divided with 2 and I multiplied with 2. Got it? And these two will get cancelled, minus into minus will be plus, sin h by 2 divided by h by 2 when h approaches 0 is 1. Okay, and we have sin x, and let me write cos square x as cos x into cos x. Okay, 1 by cos x is secant x, and into sin x by cos x is tan x. So dear students, we have proved that secant x derivative is secant x into tan x. Therefore, what we have proved until now, let me revise it. So we have proved this until now. In our first video, we have proved that x power n derivative is n into x power n minus 1, and in this video, we have proved the derivatives of these functions. Now let us see what is the derivative of inverse trigonometric functions. What is sin inverse x derivative, cos inverse x derivative, tan inverse x derivative, and the remaining three inverse trigonometric functions derivative. Okay, so let us continue with doing inverse trigonometric functions derivative, and this is what you are supposed to do. I didn't mention this before. Don't forget to complete finding cosecant x derivative. Okay, so let us continue with the sin inverse x derivative. So let us see how to prove that sin inverse x derivative is 1 by root of 1 minus x square. We can use fundamental principle of derivative, but actually that particular method is a little bit lengthy. So, and it also needs us to use the formula of sin inverse x minus sin inverse y. So to avoid all these proofs, let us use a different method. In that, one thing you have to remember is, dear students, if y is f of x, then dy by dx, the derivative of y with respect to x, is f dash of x. Okay now, and what if x is dependent on y? If x is a function of y, then we can find dx by dy, which means the derivative of x with respect to y, and that will be equal to f dash of y. So remember this before we start proving sin inverse x derivative. Okay now, so fine, let us start doing sin inverse x derivative. So let f of x, or let sin inverse x, let sin inverse x is equal to y, and we should all know what is the domain of sin inverse x and what is the range of sin inverse x. Here x can be any number from -1 to +1, and y can be any angle from -90 to +90. This is the range of sin inverse x, and this is the domain of sin inverse x. So when I am writing sin inverse x is equal to y, it means that x is only any real number from -1 to 1, and y is any angle from -90 to +90. Keep this in mind. Okay, so now, dear students, since sin inverse x is y, I can write x equal to, when sin inverse goes that side, it becomes sin y. So x is equal to sin y is in the form of x is equal to f of y, and we told you that dx by dy, derivative of x with respect to y, is f dash of y. Okay now, so therefore I am finding dx by dy first, and after that I will tell what is dy by dx. So dx by dy is equal to what? Sin y derivative with respect to y. Sin x derivative, dear students, sin x derivative with respect to x is cos x. Then sin y derivative with respect to y. Sin y derivative, what is it? Sin y derivative with respect to y is cos y. So therefore dx by dy is cos y. Now, if sin y is x, then what is cos y? Using identity, what is it? Sin square y plus cos square y is equal to 1. So sin y is x, you can substitute here. X square plus cos square y is equal to 1. From this you will get cos y is equal to plus or minus root over 1 minus x square. In one step you will get this. You will get cos y is equal to plus or minus root over 1 minus x square. But please observe one thing, dear students. You are trying to find what is cos y, and y is between -90 and +90. So this is -90 and this is +90. When angle y is between -90 and +90, our angle y is either in first quadrant or in fourth quadrant. Correct or not? In both these quadrants, cos y is positive or negative? Obviously positive. So cos y is taken as only plus root of 1 minus x square. We are not taking minus. We are not taking minus here because y is an angle in first quadrant or fourth quadrant, and in these two quadrants cos y is positive. So I will take only plus symbol. This is very important while solving questions on inverse trigonometric functions. Okay now, so I just got what? So therefore I got dx by dy is equal to root of 1 minus x square. But derivative of sin inverse x, if sin inverse of x is y, y derivative is nothing but dy by dx, correct or not? I have to find dy by dx from this. So take reciprocal on both sides, you will get dy by dx is equal to 1 by root of 1 minus x square over. So dear students, I will write it here. So therefore dy by dx is equal to 1 by root of 1 minus x square. So dear students, if y is sin inverse x, then what is dy by dx? 1 by root of 1 minus x square, or sin inverse x derivative is 1 by root of 1 minus x square. See, this is nothing but this. Sin inverse x is y and its derivative means dy by dx. Keep this in mind. Okay now? So using this I will prove what is the derivative of cos inverse x. Actually you can follow the same method. You can follow the same method and you can find the derivative of cos inverse x. Why can't you pause the video and try it? Why can't you find the derivative of cos inverse x using this method? You will understand better. But instead of using this method, I will use a different method. So we are supposed to find what? Cos inverse x derivative. Correct or not? So from inverse trigonometric functions, do you remember this formula? Sin inverse x plus cos inverse x is equal to pi by 2. We can call this as identity also. Sin inverse x plus cos inverse x is equal to pi by 2. Always for any value of x in the domain of these two functions. That means what? When x belongs to minus 1 comma plus 1 with closed brackets. Sin inverse x plus cos inverse x is pi by 2. So therefore, dear students, instead of cos inverse x, what can I write from here? So instead of cos inverse x, I can write pi by 2 minus sin inverse x whole derivative. So in upcoming videos you will learn that in addition or subtraction I can separate the derivatives. So pi by 2 derivative minus sin inverse x derivative. So in our first video we have learned that a constant derivative is 0 minus sin inverse x derivative we have proved 1 by root of 1 minus x square. Therefore, dear students, what is cos inverse x derivative? Cos inverse x derivative is minus 1 by root of 1 minus x square. So this is cos inverse x derivative, right? Next, so we have completed the derivative of sin inverse x and cos inverse x. Next, let us see how to find the derivative of tan inverse x. Let us see how to prove the derivative of tan inverse x, which is 1 by 1 plus x square. Obviously, let y equal to tan inverse x, or tan inverse x is equal to y. Keep this in mind. Here x can be any real number, but y, what about y? Y belongs to open bracket minus 90 comma plus 90. This is the range. This is the range of tan inverse x function. So keep this in mind. Now tan inverse will come this side. It becomes tan y equal to x. Tan inverse can come left side and become tan only when x is in the domain of tan inverse function. But x can be any real number na, so no problem. Tan inverse x can come left side. So tan y is equal to x. I got tan y is equal to x. What is our next step? Let us find dy by dx. So tan inverse, if x is equal to tan y, then I am differentiating with respect to y. Okay, dx by dy. I am finding the derivative of x with respect to y. That means what, dear students? Tan y derivative. Tan y derivative with respect to y only. This is equal to what? Secant square y. Tan y derivative with respect to y itself is secant square y. I know tan y is x. I want to know what is sec square y. Very simple. From identity, secant square y is 1 plus tan square y. So 1 plus. If tan y is x, then tan square y is x square. So what we found is that dx by dy is 1 plus x square. But we are supposed to find dy by dx. Dy by dx is what? By taking reciprocal on both sides, we get 1 by 1 plus x square. Therefore, dy by dx, dear students. That means what? If tan inverse x is y, then its derivative is 1 by 1 plus x square. So the derivative of tan inverse x is 1 by 1 plus x square. So we have proved it. Similarly, we can find the proof of, we can prove that cot inverse x derivative is minus 1 by 1 plus x square, and I am going to prove it here again using the identity of inverse trigonometry. So in inverse trigonometry, dear students, we know that tan inverse x plus cot inverse x is equal to pi by 2 for all x belongs to any real number. X can be any real number, no problem. Tan inverse x plus cot inverse x is pi by 2. So to use this, okay, let me use this to find the derivative of cot inverse x. We are going to prove that cot inverse, we are finding the derivative of cot inverse x. So from here cot inverse x is what? Pi by 2 minus tan inverse x whole derivative. So in addition or subtraction we can separate the derivatives. So pi by 2 derivative minus tan inverse x derivative. So pi by 2 derivative is 0 minus tan inverse x derivative. Just now we have found it is 1 by 1 plus x square. So therefore, dear students, the answer is minus 1 by 1 plus x square. Therefore, cot inverse x derivative is minus 1 by 1 plus x square. Easy, right? I hope it's easy. So after this, let us find the derivative of secant inverse x, and using that the derivative of cosecant inverse x. That would be the last part of proof in this video. So the derivative of secant inverse x is 1 by mod x into root of x square minus 1. Okay. So As usual, let us start. Let secant inverse x. Let secant inverse x is equal to y. Then obviously we should know what is x and what is y. Just don't simply transpose secant inverse that side. Okay now. So x is what is the domain of it? Minus infinity comma minus 1 union 1 comma infinity. Okay, fine. And what is the range of secant inverse x? That means what is y? Y is from 0 to 9 by 2 with open bracket 0 comma pi by 2 with open bracket for pi by 2 union pi by 2 comma pi. So that means what? Secant inverse x can be equal to any angle from 0 to 180 degrees except 90 degrees. So keep this in mind. Now dear students, so from here I can write x is equal to secant inverse goes that side secant y. Next dx by dy, until here no issues. Dx by dy is secant y derivative. Secant y derivative is secant y into tan y. We have just learned. Next secant y is x into what is tan y? What is tan y? That is very very important. Tan y is what? Let me use the identity. If secant y is x, dear students, secant square y minus tan square y is equal to 1. So secant y is x, right? So this is x square minus tan square y equal to 1. So from here you will get tan square y is equal to x square minus 1. Tan square y is x square minus 1 and tan y is plus or minus root over x square minus 1. The thing is, I should not simply write plus or minus. I should choose either plus or I should choose minus. How to choose it? It depends on which quadrant y lies. Come back to this. Y is present in first quadrant or second quadrant. In first quadrant tan y is positive, I will take plus sign. In second quadrant tan y is negative, I should take minus sign. So for this reason, I am splitting the proof into two cases. Case 1 when the angle y is in first quadrant and case 2 when the angle y is in second quadrant. Okay now. So remember this. Dx by dy is what? We have got secant y into tan y. So let me write this here. Dx by dy is secant y into tan y. So let me write this here. Now let us continue. So in case 1, let me see what if y belongs to first quadrant. If y is in first quadrant, what is it? At the starting we have taken, okay, if y is in first quadrant, obviously tan y should be positive, right? So we will take tan y as root over x square minus 1 and hence dx by dy. What is dx by dy, dear students? Secant y. Secant y is x. Secant y is x and tan y is root of x square minus 1. So we got dy by dx is equal to 1 by x into root of x square minus 1. I took the reciprocal on both sides and I got dy by dx. So in case 1, dear students, dy by dx is this. Similarly in case 2, when y is in second quadrant between pi by 2 and pi, so I am writing tan y. What is it? Since y is in second quadrant, tan y is negative, so I should write minus root of x square minus 1. And from here secant y is x and tan y is minus root of x square minus 1. So I will get minus here. Minus root of x square minus 1. I found dx by dy. So dy by dx is minus x into root of x square minus 1. But remember one thing, dear students. In case 1, I got dy by dx as 1 by x into root of this. And in case 2, I got, when y is in second quadrant, I got dy by dx as 1 by minus x into root of this. Please observe, when y is in first quadrant, secant y is positive, so x is positive. X is positive. When y is in second quadrant, secant y should be negative because y is in second quadrant. Secant y is negative, so x is negative. X is negative, though, so minus x is what? Positive. For this reason, what I am doing is, since x is positive in case 1 and minus x is positive in case 2, I am replacing these two. I am combining these two results as dy by dx is equal to 1 by Since x is positive here and since minus x is positive here, I am replacing x and minus x with mod x into root of x square minus 1. Is it clear? That is the reason, that is how we are combining these two results. Here x is positive and here minus x is also positive, and by definition these two can be replaced with the mod x. So therefore, dear students, secant inverse x derivative is 1 by mod x into root of x square minus 1. Can you find what is cosecant inverse x derivative? So use this identity and you can prove that cosecant inverse x derivative is minus 1 by mod x into root of x square minus 1. So dear students, what we have learned in inverse trigonometric functions derivatives. So we have proved the derivatives of the 6 inverse trigonometric ratios, and I have written the formula here. So we will be using these derivatives formula directly while solving the upcoming problems. So in next video we will see what are the rules to find derivatives, basic rules. What if two functions are under addition or subtraction, how to find the derivative. What if the two functions are under multiplication or in quotient form, how to find the derivatives. So all this will be seen in upcoming videos. I hope this video was really helpful to you. If that is the case, please like the channel, like the video, and let me know if there are any comments in the comment section, and do share this videos with your friends. It will be really helpful. Thank you. See you all. This is M. Sandeep Kumar. See you in the next video.